Let's take a look at another example. Again, this should be familiar to you from the previous videos. Let's prove that the limit as x approaches 5 of x squared is equal to 25. We want to prove that. So the very first thing I need to do is get a handle on, if I start with some arbitrary epsilon, so this is going to be my scratch work. If I start with some arbitrary epsilon that's bigger than 0, remember this is a real number now, not an infinitesimal, but as long as epsilon is some positive real number, more likely than not it's going to be a very small real number, but all we know is that it's positive. We start with that and we want, what do we want to be true? Well, we want that x squared minus 25 to be less than epsilon. Again, this should be familiar from the previous videos. Instead of epsilon, we had 0.01, or 0.1, I think. But now we're just going to let epsilon be a placeholder for whatever that small error is that we're allowing. So, exactly like we did in that video, we can factor this. So this is true. This is true if and only if the factors of x plus 5 and x minus 5 are less than epsilon. And if you recall from that previous video, we had some issues here because I'll have some control over x minus 5 since that's where I'm going in the limit. Right? I know that I'm going to be able to choose x minus 5 to be less than some delta. I don't, and this will probably be a function of epsilon, but I don't have any knowledge about x plus 5. Going back to that video, remember what we did? We made this kind of assumption. We said, well, let's assume that x minus 5 is less than 1. All right. If that's true, then negative 1 is less than x minus 5 is less than 1. And then if I added 10 all the way across, I would get that 9 is less than x plus 5 is less than 11, which tells me that the absolute value of x plus 5 is less than 11. Right, so that's true, that's true, that's true. Now I know something. So I know that that x plus 5 times x minus 5, which is exactly our x squared minus 25. They're exact same expressions. Well, as long as x minus 5 is less than 1, then x plus 5 is less than 11. So this is less than or 11 times x minus 5. And I want this to be true. I want that this expression, since that's x squared minus 25, I want this to be less than our epsilon, which, putting that together, this right here tells me that'll be true if and only if x minus 5 is less than epsilon over 11. So how do I put this together into my proof? So again, my proof, I've got to start with some arbitrary epsilon and tell you what delta has to be. Coming back and looking at this, well, I need x minus 5 to be less than 1. That's one thing that needs to be true because that thing told me about x plus 5. But I also need x minus 5 to be less than epsilon over 11. It's got to be less than 2 numbers. Well, as long as it's less than the smaller of the two, then it's less than both of them. And that's exactly what we use to choose our delta. So, proof. Remember, that was just scratch work. Our proof. So we're given epsilon bigger than 0. And we're going to let delta be the smallest, so I'm going to call it the min, of both the numbers 1 and epsilon over 11. And why do I need to do that? Well, because I don't know the value of epsilon. I made this assumption. I forced this on our hands that x minus 5 has to be less than 1. And delta is the value that gives me my constraints on x minus 5. So I need it to be smaller than 1, but I also need it to be smaller than epsilon. Now, as long as epsilon's smaller than 11, then we're good. But what if this has to be true for every real number epsilon? So what if I'm just walking around and somebody gives me epsilon to be, I don't know, 22? Well, then epsilon over 11 is 2, which would not give me something small enough to force this to be happening. So I let delta be the minimum. All right, what does that tell me? Well, if x minus 5 is less than delta, then first off, we know that x minus 5 is less than 1, because delta is the smaller of these two, or I could say actually less than or equal to 1. No, sorry, I take that back because I'm making this strictly. So if x minus 5 is less than delta, and delta is definitely smaller than or equal to 1, then x minus 5 is less than 1, which tells me that negative 1 is less than or equal to x minus 5, which is less than or equal to 1, which tells me that 9 is less than or equal to x plus 5, is less than or equal to 11, which tells me that the absolute value of x plus 5 is less than or equal to 11. Further, it tells me that if x minus 5 is less than delta, then x minus 5 is less than epsilon over 11, since delta is less than or equal to epsilon over 11. So I've got two facts. I've got that x minus 5 is less than 1, which tells me, as we work this out, that x plus 5 will be less than or equal to 11. We also know that x minus 5 is less than epsilon over 11. Putting that together, then, so if x minus 5 is less than delta, these things are true, and what else is true? Well, x squared minus 25, the function we're trying to get a handle on, is equal to x plus 5 times x minus 5, and x plus 5 is less than 11, and x minus 5 is less than epsilon over 11, and this just equals epsilon. Therefore, the limit as x approaches 5 of x squared is equal to 25. So let's do one more example. Let's prove that the limit, prove that the limit as x approaches 25 of x squared minus 625 all over x minus 25 is equal to 50. Exactly coming out of the example we worked out before, but now we're looking at limits, and the same intuition in the previous work gives us all the help we need here. So our scratch work, we want x squared minus 625 all over x minus 25 minus 50 to be less than epsilon. When x minus 25 is less than delta. So we got to figure out what our delta needs to be. Except for if you watch that video, you know exactly what we're going to do here, that this guy is equal to x minus 25 times x plus 25, all divided by x minus 25 minus 50. cancel, cancel, which is equal to x plus 25 minus 25, which is just equal to x minus 25. So lo and behold, they're actually exactly the same statements. So as long as x minus 25 is less than epsilon, we're good to go. So what's the proof look like? Proof has the same structure. We've got to start with some arbitrary epsilon. Once we have that, we choose our delta. So proof. Given epsilon bigger than 0, let delta equal epsilon. If x minus 25 is less than delta, which is epsilon, then what? Well, I'm just going to repeat the same argument. Then what's true? Well, x squared minus 625 all over x minus 25 minus 50 is equal to, and I'm not going to, well, I guess I will, x minus 25, x plus 25, divided by x minus 25 minus 50, which is equal to x minus 25, which we know is less than epsilon. Therefore, the limit as x approaches 25 of x squared minus 625 all divided by x minus 25 is equal to 50. All right, so that's the formal use of epsilon delta. This is again how you define limits without going to the hyperreals. I'm guessing that looking at these arguments that they're not probably as intuitive as the limits have been with hyperreals. I could be wrong, but in my experience, it's not the case. But you need to be aware of this definition, and all that it's really saying is that provided, so when we talk about a limit existing, we're saying that I can make x close enough to c such that the output is as close as I want it to be to L. All right, best of luck with your studies, and happy